So this is a theorem from Calculus 1. If U is an interval and f prime of x is greater than 0 for each x in U, then f blank. All right? That's 1, 2, f prime of x less than 0 for each x in U, then f fill in the blank. Do you guys know? Surely you know. F is what? Increasing, right? On U is decreasing. In fact, you probably took essentially what I just wrote as this theorem as your definition of increasing and decreasing, many of you. But the truth is, increase and decrease is a concept that extends well past the realm of just differentiable functions, right? We can talk about increase and decrease for general functions of real value functions at least. So this will be a useful theorem for us as we come back to my claim that the square root's an increasing function, right? So like if I go, let's see, what example am I on here? Example 8. So let's think about it. F of x equals the square root of x for, x an element of 0 to infinity, right? Then what? F prime of x is what? 1 over 2 square root of x, right? In calculus. And that is greater than 0 for x greater than 0. So I guess, all right, fine. To be fair, let's limit the discussion here to not include 0, okay? Let's not include 0 for the sake of brevity here. Not include 0. So then what? Thus, f is increasing. Hence what? A less than b implies the square root of a is less than the square root of b, right? There's a precursor here if a and b are positive, right? In fact, this is still true if we allow a to be 0 or b to be 0, right? What I'm saying still is true for non-negative numbers. But that's how I'd prove what I wrote in red over there. I'd just use calculus. Now, there are other arguments you could give, but this is an argument I like. See, because we can easily argue pretty much the same for any, what? How about this? Let's bump it up a notch. Suppose we look at f of x equals to, say, x to the power alpha. Then what's f prime of x? Alpha x to the alpha minus 1, right? So, given x is positive, we find what? F prime of x, alpha x to the alpha minus 1 is positive, provided what? What condition on alpha? Alpha is positive, right? So we just did this previous example, alpha equal to a half, right? But in fact, if we have any positive power function, we have, a less than b implies a to the alpha less than b to the alpha by this calculus. All right? Okay, so one other thing I should talk to you guys a little bit about. That's one thing I want to help you out with. By the way, the quiz Thursday is not definition based. It's going to be like a short proof. So, because I've kind of run out of definitions. So you're like, well, you just defined increase and decrease. No, that's not where we're at the moment. Well, I want you guys to do some homework on that and stuff, and maybe that'll come up on the test or something, but that's not the quiz. All right, so that's one thing. So the quiz should be a proof, maybe something about odd, even, probably in all likelihood. You know, divisibility, these things are possible, all right? Something like we've done in class, proof-wise, probably. It shouldn't be too hard. You won't have a lot of time to start a class. Okay, so my last comment for today is concerning, you know, nonlinear inequalities. Like, how do we solve these? So next class, we're going to be talking about set theory, you know, and unions and intersections, all that jazz, and that's great. But in your homework, there are some problems which are really about understanding a set that's characterized by some kind of inequality. And so it's important that you have a full working knowledge of the tools we have to solve inequalities, right? And so chief among these is the intermediate value theorem. What's that say? IVT. It says the following: if f is continuous on a closed interval a to b, then f attains all values between f of a and f of b. Now, we don't usually apply it directly like that. We apply this idea somewhat indirectly, and typically we apply it to the context that f of a is negative and f of b is positive, or vice versa. So let me just give you an example. Kind of gory, but this will do it for today. Suppose we want to solve the inequality x to the fourth minus 81 over x squared minus 3x minus, I don't know, 10, less than or equal to 0. How do you solve such an inequality? So the way to do it is to factor to start with. So we've got, you know, x squared plus 9 times x minus 3 times x plus 3 divided by, that's going to be x, let me do that up. Let me do the denominator over here. X minus 3 halves, quantity squared, minus 9/4, minus 10. Let's see here. So that's what we got. Oh, whoa, dudes. That's pretty cool. Is that right? 49 over 10? When I complete the square? I think I get 49 over 10 because I have to subtract the square of 3 halves, which gives me 9/4, and then turning a 10 into 40ths gives me 40 40ths, and minus 49 tenths. Hey, that's cool. So this factors then as x minus 3 halves plus 7 over the square root of 10, x minus 3 halves minus 7 over the square root of 10. All right. And so the problem we're given is equivalent to the problem I write. How do you solve such an inequality? Well, you have to come to terms simply with where you can change signs, right? The only places where we can change signs are either where the numerator is 0 or where we have like a vertical asymptote, right? The reason that's true is essentially the intermediate value theorem. So I can draw a number line down here. I put all my critical numbers. You guys are going to have to help me. Can you guys punch it in the calculator? Like, what's 3 halves plus or minus 7 over root 10? What's that work out to? And I need decimals because, you know, that's how we compare numbers. I mean, 3 and minus 3, that I understand, right?
4.66 or no, sorry, that's wrong. Sorry, it's 3.71.
For the plus?
Yeah.
And the minus? All right, so it looks like we've got 3/2 plus 7 over root 10 for there. And the minus, so there, this one's here. So those are my 4 critical numbers. All right. The x squared plus 9 is positive. It can never change sign. So these are the only places I have, these 4 places I can change from plus to minus. And tell you a trick. The trick is just start on the left or the right and you can go over. So if I go to the most right, if I plug in like a really big positive number, plus, 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 plus. So as we start out plus, the good news here, it's really simple to think about. Every one of these factors appears as a single, which means it's going to flip signs each time. So you're going to get minuses if you plug in a number here, you get pluses if you put a number here, you get minuses if you put something over here, and you get pluses if you put a number in over here. So the solution to this inequality, I told you guys I'd go over, I'm sorry, I seem to be fulfilling the prophecy. So the solution here is minus 3 to 3/2 minus 7 over root 10, all right, unioned with 3 to 3 plus 7 over root 10. So basically, these are the places I have less than or equal to 0, right? Now you guys tell me, should I include or exclude the endpoints? The plus and the minus 3 I include because that makes the numerator 0, which makes the fraction 0. So I do square brackets here, square brackets there. But the other ones give me division by 0, so I must exclude those from the solution set. I put a parenthesis here, I put a parenthesis here, and this, my friends, is the solution to this nonlinear inequality. Yep.
Did you factor the bottom right?
I hope so.
Wouldn't it just be x minus 5 times x plus 2?
That does seem right. Oh man. X minus, let me. Huh.
I think when you took the 3 over 2 and squared it, it should be positive 9/4.
No, it has to be minus because you have to subtract off this completing the square. Oh, it's not. I should have done fourths, not tenths. I'm a dummy. That was a fourth. That makes this a 2, which makes this, like you said, 5 or minus 2. All right. Well, it would have been nice to hear this 3 minutes ago. But anyway, my stupid errors aside, the technique should be clear. Yeah? You write down the number line. So I talk about sign charts in like the next mission. That's what I'm talking about. Make sure you get your quiz before you leave.